Hi there. Hope you have a fantastic day today. This lesson, I will go through 2021 HSC papers. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 21. So y is equal to 4f of 2x. So first of all, we know that f of 2x, that means it is a horizontal dilation with a factor of a half. So let me just write this down. And for f of x, so that means it is a vertical dilation with a factor of 4. So 4 times f of x. So that means 4 times y, if you like. So let me just draw out the number plan first. So this is x and this is y. So first of all, this is 6 here. We have a horizontal dilations of factor of a half. So a half of 6 is 3. So let me just change that to 3. And a half of x, that is half of 4, is 2. So the turning point here is along 2 somewhere here, okay? So roughly here, along this line, if you like. So then the vertical dilations factor of 4. So that means 4 times negative 8 is negative 32. So roughly here, okay, which is roughly. That's all. Let me just clear this first. So there you go. So 2 negative 32. And then half of 0 still give me 0. And then the vertical axis, that is y-axis. So 4 times 0 still give me 0. So the 0 stay the same. So now I just quickly join these points together. So there you go. So this is y equal to 4f of 2x. So there you go. Question 22. So this table here is showing the probability from 0 to z. In another word, if z is 0.3, so this means that the probability from 0 to, let's say, z less than 0.3. That's what that meant, okay? So that will give me 0. This number here, 1179. Okay, so keep that in mind. Now the question is, we need to find the probability that is lie between 0.1 and 0.5. So in another word, we need to find probability of z between 0.1 to 0.5. So that is equal to the probability z less than 0.5 we minus probability of z less than 0.1. So in another word, we can just find p of 0.5 minus p of 0.1. So p of 0.5 is this number here, and p of 0.1 is this number here. So we just go 0.1915 we minus 0.0398. That is 0.1915 we minus 0.0398. So there you go, 0.1517. So 0.1517. There you go. Now part B. So first of all, we know that the mean is this grams and the standard deviations is this. So let me just make note on this, okay? So this is the average, the mean, and this is the SD, standard deviations, okay? Keep that in mind. And first of all, we need to find the z-score so that we can find the expected number of babies born that is greater than 3,528 grams. Okay, so let me just convert 3,528 into Z score first. Okay, so we know the rule for Z score is this: Z equal X minus X bar, that is the mean, over the standard deviations. So we know that X is 3,528. And we minus the mean, that is 3,300, over the standard deviations, that is 570. That will give me fractions 3,528, we minus 3,300, and then over 750. So there you go, SD. So 0.4. So Z score is 0.4 and have to be greater than this. So in another word, we need to find the probability that is Z greater than 0.4. So now we know that greater than 0.4 is, let's say Z is 0.4. Let me just redraw this so you can see what it is. So this is 0, this is 0.4, and what it means is we need to find this probability. And we know that from here to here is 0.5. Now to find the shaded area, we just need to find 0.5 minus this bit. So this bit here is Z between 0 to 0.4 is this number here. Okay, keep that in mind. So probability of Z from 0 to 0.4 is 0.1554. Okay, so that is equal to 0.5 because from halfway is 0.5. Okay, and then we minus probability Z less than 0.4. That will give me 0.5 minus Z less than 0.4. That is between 0 to 0.4 is this number here, 0.554. So we minus 0.1554. So that should give me, so just go 0.5 minus 0.1554. So there you go, 0.3446. So 0.3446. So that is a probability. So let me just write it on here. Now we need to work out the number of baby expected to be born that is greater than 3,528 grams. So out of 1,000 babies. So the expected is, so that become 1,000, and which is times by 0.3446. So that will give me 344.6 babies. So there you go. Question 23. So first of all, we know that P is for populations and B is a positive constant, a positive number if you like, and T is the time in years. So that's what we need to understand first of all. So we know that the populations is 1,250 after 20 years. So we can use these values to work out the value of B, the constant if you like. So first of all, P is 1,250 is equal to 5,000. B negative T, now T is 20. So we just write 20 over 10. And I can just simplify this. Divide by 10 both sides. And this 20 divided by 10 is 2. So let me just rewrite this. So that means 125 equal to 500. B power of negative 2. Like that. So now what I do, I divide it by 500 on both sides. So this means that this is 500 and this is 500. So cancel it out. So now this becomes 125 over 500 is b negative 2. So this is exactly the same as 125 over 500 and 1 over b squared. Because I just bring the negative index, bring it down, become positive index. That's all. So what I do, I flip both sides. So this becomes like this. 500 over 125 is equal to b squared. So now 500 divided by 125 is equal to 4. Otherwise, you can just use your calculator. So that means b squared is 4. So therefore, b must equal to plus or minus 2. But then in this case, b is greater than 0. So therefore, b is equal to 2. So now the equation is this. P is equal to 5,000 b, but b is 2. Power of negative t over 10. So the question is, we need to find the value of t for which the instantaneous rate of decrease is 30 people per year. So in another word, dp dt, let me just note this down for you. So dp dt 30, but it's negative because it decreased. Okay, keep that in mind. So now what I do, I need to differentiate this function here first, dp dt. And the rule for this is, so let me just write this down. So if we differentiate, y is a f of x. So y dash is f dash x, a power of f of x, and times by ln of a. Okay, this is the rule that we are going to use. So now what we do is we differentiate the function first, f of x. So negative t over 10. So differentiate that, give me negative 1 over 10. So therefore, let me just write dp dt first. So dp dt is equal to negative 1 over 10. And we times the function. So that is 5,000 and 2 power of negative t over 10. And then we times by ln of a. A is 2. So now there you go. So now I just simplified this. So let me just write this on here. So now this means that dp dt is equal to, so we can simplify this, that cancel with this, so that become negative 500. So negative 500 and ln of 2, and then we times by 2 power of negative t over 10. And we know that dp dt is negative 30. So this means that negative 30 is negative 500 ln of 2 power of negative t over 10. So if I divide it by negative 500 ln of 2 on both sides, so this will give me, so I can just simplify this 0 first if you like. So that becomes 3 over 50 ln of 2. That becomes 2 negative t over 10. So let me just use calculator, work out the left hand side first. So that will give me, so just go 350 ln of 2, close brackets. So there you go, 0.0865 and so on. So 0.0865 equal to 2 negative t over 10. So if I take ln on both sides, so that will give me ln of 0.0865 is ln of 2 negative t over 10. So what I can do, I can bring the negative t over 10 down by using log law. So that becomes this. That give me negative t over 10 ln of 2. So now I times 10 on both sides. So that will give me 10 ln of 0.0865 equal negative t ln of 2. And I divide by negative ln of 2 on both sides. So that will give me negative 10 ln of 0.0865 over ln of 2. That give me t. So therefore, t equal to, so I just put on a calculator. So that should give me, so just go negative fractions 10 ln the answer. That was the last one I did, 0.0865 and so on. I close the brackets and I go down ln of 2. So there you go, 35.30 and so on. So let me just write this down, 35.30 and so on. But the question is, we need to give answer correct to 1 decimal place. So therefore, t is 35.3 years. So there you go. Question 24. So first of all, to work out the area of this region, so we need to understand that this is 2 sections here. Okay, from 0 to 2 is this function here. And from 2 to 4 is this function. This function here is y equal 3x minus 1. And this function here, y is 3 over 2x. So I just need to work out area A. This is just like A1 and this is A2. So I find A1 and find A2 and we add them up. So that gives us the answer. So that means A1 equal, so we integrate from 0 to 2 and the function is 3 over 2x dx. So I can take 3 over 2 out, make it easier. And you don't have to, but easier, that's all. So that is equal to 3 over 2. We integrate from 0 to 2, x dx. So we integrate x, give me x squared divided by 2. So x power of 2 divided by 2, okay, if you wish. So like this. So x squared divided by 2 from 0 to 2. So therefore, I can just take the 2 out because it's a half x squared, if you like. So I take a half out, so give me 3 over 4, like this. So x squared from 0 to 2. So now to evaluate this, so x becomes 2, 2 squared is 4. So 3 over 4, so 2 squared is 4, minus 0 squared is 0. So that will give me 4 times 3/4. So give me 3 square units. So that is area 1. So A2, so let me just write here. So A2 is these functions from 2 to 4. And then the function is 3 over x minus 1 dx. So I can take the 3 out. So if I take the 3 out, that becomes like this. Integrate from 2 to 4. This is 3 out. So 1 over x minus 1 dx. And don't forget the numerator function here. If you differentiate the denominator, so differentiate x minus 1, give me 1. So in another word, if we integrate f dash x over fx dx, so that will give me ln f of x. And we add a c, of course, a constant. But in this case, we don't have to because it's definite integration. So we can ignore the c, okay? So that will give me 3 ln of x minus 1. And then from 2 to 3. So now I just go 3. Now, if we substitute 3 in, 3 minus 1 will give me 2. So that means ln 2. Minus, So 2 minus 1, because the x is 2. So 2 minus 1 is 1. So that means ln 1. So there you go. But then ln 1 will give me 0. So the answer is 3 ln 2. So that is area 2. So now we just add that two areas together. So therefore, area will give me, so 3 units plus 3 ln of 2 square units. There you go. Question 25. The table shows future value of annuity of $1. So we know that Simon deposited $1,000 into his saving account at the end of each year for 8 years. And the interest is 0.75% per annum, compound annually. So that means we know that is N is 8, R is 0.75%. So that is the information we know so far. After 8 deposits, so he changed into a different saving account. That is 1.25% per annum and compounded yearly, annually, if you like, for further 2 years. So first of all, we need to work out how much he has at the end of 8 years first. Okay, so from the future value table. So now for 8 years, which is 0.75%, so N is 8 and 0.75%, that is the future value. So let me just write this down. So the annuity of $1 is 8.2132. But then he deposit 1,000 instead of $1. So then from here to here, we times by 1,000. So therefore on the right hand side, we need to times by 1,000 as well. So we move 1, 2, 3. So 8213.20 because it's money 2 decimal place. So that is how much in his account, okay, at the end of 8 years, if you like. But then after 8 years, he's gonna put this into a different account for further 2 years with the interest rate of this per year. So therefore, we know that the future value is present value 1 plus R power of N, or A equal P bracket 1 plus R power of N. Okay, this is the same thing. So now we know that the present value is 8213.20, 1 plus the interest rate 1.25%, power of 2, because 2 years. So now what I do, I just put down a calculator. So that will give me 8213.20 brackets 1 plus 1.25 over 100, and we square it. So there you go, $8,419.81, because we're dealing with money, so 2 decimal place. 8419.81. 8419.81. So therefore, his future value is $8,419.81. So there you go. Thank you so much for watching. Bye.